All right, let's give everyone just a couple moments to kind of drop on in, send out the announcements and say, hey, Tech Art Talk Live is now live. Who would have thought? Position myself right in the middle of the screen. All right, we've been broadcasting long enough. Let's get this show on the road. Welcome, tech artists from around the world. It's Friday, and it is 12:30 Eastern Standard Daylight Time, and that means it's time for another episode of Tech Art Talk Live. My name is Chris, and I'm going to be your host for today's session. Now, we've been dealing with a lot of things that have been rendering and shading oriented lately. Like a couple weeks ago, we dived into the multiple wonderfulness that is ray marching. But we kind of skipped over something really important when we were dealing with all this cool ray marching stuff, and that is, wait a second, we're programming in a shading language. And I had neglected to teach all you folks out there how to program shaders. And so that's what we're going to do for now and the next bunch of weeks. We are going to go into and take a deep dive into shading languages. Now, what we're going to do is actually focus on a shading language called HSL. Now, there are two, well, there are kind of like three really, but there are two basic primary shading languages. There's HLSL and GLSL. HLSL is originally developed by Microsoft, and it supports the DirectX 12 protocol. And then GLSL is the OpenGL standard. Now, OpenGL is kind of evolving into Vulkan, and I'm not sure exactly. Maybe you can type in if Vulkan is going to be HLSL or GLSL. I'm not really sure. My guess is that it's probably GLSL. But let's see, why HSL? Why HLSL? Because primarily, like, it's kind of like a universal language that, you know, it's close enough to GLSL that you could almost like bat your eye and then it almost duplicate it, and it's like basically the same. Both Unity and UE4 have custom nodes that are written and accessible in HLSL. And so therefore, and if you go into like UE4, almost like Niagara is entirely all written in HLSL. And if you really know your HLSL, you can just dive right in there and create another custom node or an expression. Just dive right in there and then do what you want. So it really has a lot of opportunity. HLSL, GLSL, it doesn't really matter so much. But you got to choose one. So therefore, I'm choosing HLSL. Well, primarily because it's most akin being used inside UE4, and it's the one I am most familiar with at this moment in time. So therefore, HLSL is the winner. All right, so let's get started in talking about HLSL and about shading languages in general here. All right, now we're calling this HLSL Baby's First Shader. Thank you, tech artist extraordinary Mary Denman, for inspiring the name for this first shader because, well, primarily she had the job that I have before I did, and she created everything like with Baby's First Shader, and I thought of Mary when I was thinking of this. So thank you very much, Mary. Anyway, let's get this going. Okay, in order to actually program in shading languages, you gotta remember the graphics pipeline. Now, we've been over the graphics pipeline before, and that was actually an episode that was done from probably about a month and a half ago. But let's go over it again just as a real quick recap. All right, there are basically 7 stages to the graphics pipeline. And the first stage is the input assembler stage. The second stage is the vertex shader stage. The third is the hull shader, well, it's the tessellation stage. The fourth is the geometry stage. Then we go on to the rasterizer, then to the pixel shader, or it's also called the fragment shader. And then finally, we're going to wrap things up with the output merger stage. Now, we're going to focus primarily just on 2 of these shaders right now, just because That's where most shader writers spend most of their time, and we will eventually go into some of these other ones at a little bit later time in a few weeks, but let's start walking before we begin to run, right? Okay, so what we're going to do today is we're going to deal with the vertex shader. Okay, the vertex shader is very important because what this does is it translates all the vertices of your model into object display space, and so that puts it into the display space, and so that conforms it and makes it ready to rock and roll. All right, and then what we're going to do is we're going to talk about the pixel shader. Now the pixel shader is where the geometry has already been converted into pixels through the rasterizer, but the pixels don't have any color yet, and so the pixel shader tells the pipeline how to actually color in each of the pixels. And so what we're going to be doing is going over the very, very, very basics of how to write a vertex shader and how to write a pixel shader in today's lecture. Okay, now in order to use this, we're going to use a tool called ShaderEd. Now ShaderEd is a cool program because you can download it for free. It's an open source. You can choose to program HLSL or GLSL, and I've even seen people using it for Rust and other languages, and which it works with, I'm not really sure. Now I gotta have my caveats. I'm just learning ShaderEd, and it's not the one I typically teach from. I usually teach with a tool that you can download from Steam. It's called Shader Tool, and it's created by a company in Germany, which I really like, and it's a little bit more intuitive. But since ShaderEd is free and it's open source, that's what we're going to use for today's lesson. So please be patient with my ignorance as far as ShaderEd is concerned. But anyway, ShaderEd's cool because we can do HLSL or GLSL or any other language, and it's really good to go. So I'm going to post the location for ShaderEd inside of the description at the end of this session. So it's not there right now. So what you would probably want to do is watch this video and or put it on pause and come back to it once you've downloaded ShaderEd to your machine, and then you've installed it. And then once you have installed it, then you can kind of go through all this and follow with me again. All right, now let's go ahead and start dealing with ShaderEd here. Now when you first open up ShaderEd, you're going to end up with something that looks like this. Ooh, you're probably going to end up with something that looks like this. Yeah, there's nothing in there. Okay, so let's go ahead and start putting stuff into there. So we're going to start off by, we're going to create a brand new project. I'm going to File, I'm going to go to New, and we're going to go to Empty. Okay, that's going to create a new empty project here. So we're ready to rock and roll, and we don't have anything in it. And so what I like to do in ShaderEd first is you create a brand new project, I like to go ahead and save the project and give it a location inside of your disk. So go File, Save As, and then I am going to save it as blah, blah, blah. Okay, here going to F and to go to TechArt.edu, and then this is TATL, and boom, 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 boom. 51, ShaderEd, and ShaderEd, and then let's call this new project, oh yeah, I like to call this Baby's First Shader. So Baby's First Shader. Isn't that cute? Okay, save. Okay, there we have our new shader project. Okay. Now, once we've gone ahead and do that, we're going to create something called a shader pass. Now, every tool seems to have its own idiosyncrasies here, and ShaderEd is no exception. And so it creates things with constructions called shader passes. So what we're going to do is we're going to go to Project here, Create, and we're going to create a brand new shader pass. Okay, now we get this little window here, and hopefully you guys can focus in on it and see it. But we're going to call this first Baby's First, or just BFS, for Baby's First Shader. Now we want to change the language from GLSL, we want to change it to HLSL. Okay, now notice here that it's going to start looking for a vertex shader path and the shader entry and then a pixel shader path. Because like I said, we're only going to be dealing with the vertex shader and the pixel shader. Now, where it says vertex shader entry, I'm going to change the name from main, and I'm just going to call this vertex shader. And then for the pixel shader entry, I am going to call this pixel shader. Now, just as a reminder, a lot of you folks, if you're using something like Shader Toy that's on the internet, they won't call it a pixel shader, they call it a fragment shader. And I think fragment shaders are pretty much reserved for, especially for GLSL, but honestly, pixel shaders and vertex shaders are really kind of the same thing. All right, now those are the only two things that we really want to. Geometry shader, okay, we don't have a geometry shader in here, so let's scroll on down here, down to OK, and click OK. And then here we have is this OK. Then we have all this stuff in here, and let's look at here. Oh, wow. It created a bunch of stuff for us. BFS, okay. It created a bunch of stuff for it. It's not supposed to have this in here. Why did it do that? Get rid of it. We don't want it. It must have copied something from the buffer. But anyway, you should end up with something look like this. You should have nothing in the vertex shader, which is abbreviated for VS, and nothing in the pixel shader, which is abbreviated with PS. Okay, we're going to start off. Oh, before we create the shaders, we got to have some geometry, right? Because we got to view something. So let's go ahead and create a venerable cube. Okay, so where it says BFS right here, and here, we're going to right click on here. We're going to go add geometry. All right, and we're going to call this boxy. And then we're just going to create a geometric type and the size 111. All right, keep it as a default. Let's keep it simple. Okay, so we have a box. Now notice we don't see anything in our little view window. Why don't we see anything? That is because we haven't written the shaders for it, so we don't have any way of visualizing it yet. So don't worry that you don't see anything. We're going to be working on that right away. All right, now what we're going to do is we're going to start modifying the vertex shader, and I'm going to type in the first thing we want here, and that is we're going to create a context buffer. Now a context buffer is going to give us a little bit of frame of reference and for this. Now we can make this buffer as large as we want. Now those of you who understand a little bit of C and C++ would recognize this as a structure that we're creating, and we're declaring a special structure, and it's of type called CBuffer, and we're calling it locally as CBufferPerObject. So that means we're going to create one of these C buffers or context buffers for every one of our objects that are in the scene. All right, now inside of this, we're going to create a float 4x4, and a float 4x4 is a special word for a matrix, a 4x4 matrix. Now, if you don't know what I'm talking about, is for a 4x4 matrix, that means it's 4 numbers across and 4 rows deep, and so it has a whole bunch of stuff. There is a TechArt Live presentation, from maybe about a half year ago, where we talk about matrices and transformations. Go review that one again and check that out, because it'll tell you what we're talking about here. And we're going to call this matrix the worldview projection. And notice here we have a little colon, and it says worldview projection on here. Okay, what this little colon and this little word afterwards, this is called a semantic. And a semantic gives the shader, or gives the pipeline, a little clue on how this variable is going to be used. Now, not all of these semantics are necessary. Sometimes these semantics are absolutely necessary. And I'm going to show you which ones are or which ones are not, and I'll do my best. But anyway, we're just labeling this as worldview projection because that's how I want to use this. All right, so let's go ahead and then write our first vertex shader. Okay, now it starts off with a return value, which is a float 4. So that means we're going to return a vector that has 4 float values into it. And what they do is they correspond to red, green, blue, and alpha. And so the name of our function is called vertex shader. Remember how we typed in vertex shader in the declaration when we create our shader pass? Well, this is what we're creating. It's called vertex shader. Okay, inside of it, you see what is inside the parentheses here. These are the arguments that this shader needs in order to function. And what we're sending it is a float3 of the object position. And notice that it has the semantic of position. You're probably going, hey, Bub, why is this float3 and we're going to return a float4? What's the difference? I'm glad you asked. Okay, a float3 is a vector that just has 3 values in it, and it corresponds to just position, so therefore it's got x, y, and z value in it. Now we're returning a float4, which has x, y, z, and w. If you don't know what w is, don't worry about it. It's an element component in the worldview transformation pipeline, and just kind of like accept that you got to have it along even if you don't really understand what it is. Now notice here that the declaration of this shader here is finished with a colon and SV position. Colon SV position is a semantic that is absolutely necessary when you're creating an HLSL shader. And it's necessary because it identifies or tags this as the vertex shader. And that's all it really does. Okay, so let's take a look at the contents of our vertex shader. The first line here, we're declaring a float4, and we're calling it nope, or the original vertex position. And so what we're doing is we're taking the object position, and then we're going to append one value to it. So this is what's called a casting. We are going to be casting our object position. We're going to be casting it to a float4, and notice the thing that we're going to be appending onto it is just a 1 at the end. Why is it going to be 1? Because when you're dealing with that w value coming in, if it was just a direction, it would have a value of 0. But because we're dealing with an actual point position, then we got to use the value of 1. So now this nop value, or n object position, then corresponds to the object position with a 1 slapped onto the very end of it. Now what do? We're going to return this value, but first what we're going to do is we're going to multiply our nop by the worldview projection. Okay, what this is doing is it's taking it, when you build your model, it's inside model space ultimately, and if it's like in Maya or Houdini or someplace, and it's sitting around in the Houdini taste, then it's sitting around in local space, divided by 0, and it's at the origin and so forth. But in order to get it to go into the display, we have to transform it into display space. And that's what we're doing right now, is when we multiply our object vertex against the worldview projection, it's transforming it from local object space into screen space. And so there's a whole bunch of math that's going on here, and it's a little bit voodoo and a little bit magic, but that is what we're doing. And this is the ultimate goal of what the vertex shader is supposed to do. Okay, good. Now, notice here that we created something here, and it has a variable. And so what's that variable is we have to declare our variable as worldview projection, because we're hoping that the system can actually put this into this. So what we have to do is we're going to go to BFS. We're going to right-click on that. And now instead of going to add, we're going to look where it says variables. Okay, notice that it already was anticipating for us. It has a float 4x4. That means it's a matrix, a 4x4 matrix, and the name is worldview projection. And now the system, it says none there. So we have to tell it what information to actually map onto there. And so we're going to hit the triangle down, and we're going to say, okay, we have to go and we want the view projection. You're probably going, hey, wait a second, Bub, this is worldview projection. Okay, what's going on with that? Oh, we got some red stuff on here. That means it's working. Yay! Now, I shouldn't have done that. I think what's going on, I forgot to save this. But I'm going to click OK, and I'm going to save this. And oh yeah, there it goes. It disappeared again because we shouldn't have any values in there. That's Shader Tool getting a little excited for us. But anyway, That's all it is. We've created our variable, which is going to provide input from the system, and we've localized that variable, and now we're ready to rock and roll. Okay, now we're going to go on to the pixel shader. Now, pixel shaders actually are really, really simple to create, and there's not a whole lot to them at first. And I'm going to type this in here. Now, notice that that's not what I want. That's a vertex shader. Okay, get this going in here. All right. This isn't what I want. I want my pixel shader, daggone it. Yeah, that's what I need. Gonna go ahead and remove this. There, pixel shader. So you see that the pixel shader is actually pretty small. And so, like the vertex shader, we're going to return a float 4. But this time, the float 4 doesn't correspond to X, Y, Z, and W. It corresponds to red, green, blue, and alpha. And here's the declaration of our pixel shader. And now we have the SV target. Now, SV target is a semantic that is super duper important. And so what that does is it says, okay, this is the pixel shader. So SV target declares this function as the target for the pixel shader for the pipeline. Okay, I'm going to go ahead and save this. And there we go. Look at that. We heard a red cube. Now, we're looking at what it returned. We can return a float 4. A float 4 is nothing but red, green, blue, and alpha. And so let's look at the values that we put into it. So a float 4, it's casting off with a red value of 1, green value of 0, blue value of 0, and an alpha value of 1. So until we start dealing with transparencies, it's just best to kind of keep the alpha value at 1 and just kind of like keep it as is. Okay, gang, that's it. That's Baby's first shader. Okay, Baby's first shader is really, really simple. And there's a lot of stuff going on here, but there's enough to play, you know, to really cut your teeth on. But I wanted to cover over something a little bit more because it's not really that powerful yet. What we have to do is we have to convert it to something that's a little bit more user-friendly. And you're going to start to see why. Notice that it's a little bit awkward with the SV positions and the position and the semantics. They get to be a little bit cumbersome after a while. So what we're going to do is we're going to create a programming structure called structures or structs in order to help us along. And the cool thing about structs is that we can reuse them again in future time, and it will help us with our overall programming. So what we're going to do is we're going to recreate Baby's first shader, but we're going to call it Baby's first shader struct. It's going to be easier to read and easier to manage, and we're going to be using a lot of the same things. And you're probably going, well, is that possible to have more than one shader in one project? Yes, it is, and I will go over how to all do that. So what we're going to do is we're going to add some data structures. We're going to make a few modifications to our vertex and our pixel shaders, and then we're going to get ready to rock and roll. So on this project here, we're going to create, oh wait, we don't want to, do we want a shader pass? Yeah, we're going to create a brand new shader pass. We're going to go project, create, shader pass. And then the name, I'm going to call it BFSStructs. And that's short for structures. Okay, we want the language to be HLSL. And the shaders, it gets parked into this location on disk. Now I'm going to change my name to vertex shader again. Okay, I'm going to call it vertex struct shader, just to make sure that there's no confusion. And for the pixel shader, I'm going to call it pixel struct shader. All right, now this might seem like a little bit of extra work, but I promise you that this is going to pay off in the long run, and it's going to make life much easier for us. So click OK, and there it is. It's supplying stuff from old data again that's sticking around in memory. I didn't know I was going to do this. Okay, I'm going to go ahead and save this. All right, so it's saved, and so we have Baby's first struct, BFSStruct, vertex shader, and BFSStruct pixel shader. Okay, so we don't see anything in there. So what I'm going to do is visualize BFSStructs. So over here on the menu where it says a little eyeball, I'm going to click on that and it's going to kind of disappear. But notice that it didn't disappear yet because we don't have anything yet, so be patient. So what we're going to do is duplicate the exact same thing we did with BFS. We're going to click on BFSStructs, right click it, go to Add Geometry, and we're going to call it Boxy Struct. Just so we know that there's a little bit of difference. Click OK, and now it disappears. Now we have the BFSStructs and a Boxy Struct, and we have the geometry. It's in there, we just can't see it right now. Okay, so what's about this structure business? So let me show you what I mean by this. So we're going to create some new structures inside of our vertex shader. Okay. In order to create a structure, you start off with the declaration of struct, which is the kind of the key word that tells us what is going on. And then we're going to tell us what we're going to create. And we're going to call this called VS input. VS stands for vertex shader input. And so what do we want with that? We're going to send it in a float 4, which is the object position. And we're going to call this position. And then we finish that off by surrounding it by curly brackets and then putting a semicolon here at the end of the structure declaration. We're going to create a second structure declaration. We're going to call it VS output. And we're going to start it off with open curly brackets, and then we're just going to call it just plain old position. And now notice that it has the semantic SV position. Now, you have to have this SV position in here as the semantic, because that says, okay, Bub, the final vertex position is going to come through right through here on this variable. And so that's why we declared it right as that. Okay, so now let's create our vertex shader. Okay, now look at here. The return type, or what this vertex shader returns, is now a VS output. And let's see, the VS output is what we just described out here. So it's going to return the vertex shader output. Now notice that here we have our vertex struct shader. I hope I named this correctly, but if not, we're going to have an error and we're going to know where it's going. Hey, say, hey dude, you misspelled this incorrectly. So we'll see if we actually spelled it correctly or not. But anyway, let's see. Let's see. I can check it. I believe if I right click on here, if I go to properties, look at this, VS entry vertex struct shader, and I didn't use it. I used the underscores on here, so I have to change this over to here. I'm glad I checked. So this would be struct shader. All right, so now I know better. Okay, so I'm learning ShaderEd a little bit. Okay, so what we're going to put as input, we want vertex shader input in. And so this is coming from the object position. And this position, once again, is going to tell the pipeline, said, okay, wherever the input assembly is coming from, put the vertex position here in this variable, and it comes right in here. All right, now look at this. We don't have to cast it off, and we don't have to convert it to anything funky. We're going to let the pipeline do that for us. So all we're going to do here is we're going to create an output variable. And it's actually an output structure, and we're going to call this VS output, VS underscore output. We're going to call it out, and we're going to declare it as VS output. We're going to put the VS output in parentheses and then append it with a 0. What this structure actually means is that we are casting all of the contents, or taking our vertex shader output, all of the data in there, we're going to put it to 0. Okay, say, hey, don't worry about this, just make it 0. Just get rid of it and just put it to 0. Okay, then we're going to say output.position. So this is a little bit like Python, a little bit like C and C++. Notice that our data structure is called out, but when we say dot position, we are looking at an attribute inside of this data structure. So out.position is the place where we want to put the information. And where do we get that? We multiply in.objectPosition times worldView projection. Okay, remember, in.objectPosition is a float 4. And so we can multiply a float 4 by a matrix 4x4, which is in the world view projection. And then once that is computed, we're just going to return the out. Now we could have returned, no, we couldn't have. So actually, that's just the way we expect it to be. I'm going to save this. And we say, uh-oh, cannot display preview. There are some errors you should fix. All right, so I'm going to go over here to output. And it says unknown world view projection. Oh, that's because we didn't declare what world view projection was. Okay. Oh, we forgot to put in our CBuffer. Okay, so let's go ahead and grab on our old vertex shader. We're going to grab the CBuffer from here, and then we're going to put this in here. Oh, then we're putting it in the pixel shader. Oh, I don't want this. Okay, I'm going to put that here, and then I got to fix this, folks. Okay, we're going to call it CBuffer, and then there's our world view projection matrix, so we know what it says now. And then I'm going to copy all of this. I'm going to hit X, which deletes it, because I don't want it in the pixel shader. I want it in the vertex shader, right? I'm going to click over here to the vertex shader tab and make sure it's in there. And then I'm going to hit Control S to save it. And so it went ahead and fixed everything. So everything is now kosher and copacetic. Now I'm going to have to make sure that the world view projection is set properly as a local variable. So I'm going to right click this and go into variables. And where it says float 4x4 world view projection, I'm going to have to tell it I want the view projection matrix. Click OK. And we are good to go. Okay, so we've recreated our vertex shader and we've added its variables, and now we should be running along just fine. Now let's create our pixel shader. Now our pixel shader is pretty simple, and we're not doing a whole lot, but we're going to use our structures instead. Okay, so I do know that this should be pixel underscore S struct, and this should be underscore S shader. Okay, so here's our return type. It's going to be float 4, and what corresponds to red, green, blue, and alpha again. The name of our pixel shader is BFSStructs shader. Now here's our input. Now instead of putting in a float 4 as input, we have a vertex shader output as their input. Okay, so this puts in the whole structure into this. Here you can start to understand the reason why we're using structures is because our structures can be modified separately, and then we don't have to go through our code into like the vertex shader or into the pixel shader and then update all of our input values. We let our structures handle this. Okay, so that is our input, and now once again we're going to have to put a colon, and the semantic on this is SV target. That means it says, okay, get your pixel value shader data from this function right here. And so that is a necessity, that is a necessary semantic. We're just keeping it very simple again. All we're going to return is a float 4, and instead of coloring it red, what color are we going to color this? If it's 0, 1, 0, and with an alpha of 1, what color is we going to do it? That's right, it's going to be green. Remember, it's red, green, blue, so therefore we're just going to have a blue channel in here. And so I'm going to click on save, and we cannot display. Okay, we've got errors. Where are our errors? It says expected. Okay, SV target. Okay, list expected line 2. Okay, so let's see. Error at line 2. A parenthesis is expected. Okay, so what is this? I'm going to go over to my pixel shader here, and I'm going to grab this declaration, and I'm going to move this over here. I'm not sure what the error is. And then what I say is I'm going to call it BFSStructs shader again. And then as input, I want VS outputty, and then we're going to call this in, and we're just going to call SV target. All right, and so SV target is all that we need. So let's go ahead and see what's going on, and it's still not right. Okay, why isn't it? Let's go ahead and delete all this. X, and then I'm going to just click on this open parentheses and close parentheses. It did it already. Save it. It says there are some errors you should fix. It says shader source empty. Shader source empty. Yeah, that means there's nothing in here. So let's say return. And now let's go, we want 0 for red, 1 for green, 0 for blue, and then 1 for alpha. And then hit semicolon, and then S. And it is still not functioning. Why aren't you functioning? That's crazy. This is not fair. Pixel Struct Shader float 4, Pixel Struct Shader VS output in colon SV target is the result, and then we return float 0104. Okay. All right. Compiling the shaders. Okay, so everything looks proper here. Hopefully, if you're following along this home, you're not getting a lot of cacamac and a lot of garbage here. But if you are, thank you for your patience. So let's try to figure this out again. All right, so if we go ahead, I'm going to have to go ahead and type this in verbatim and see what happens again. So let's hit Control S. Okay, so nothing there, no problems. Okay, so I'm going to go, this is going to a return as a float 4, and then we are going to call this Pixel Struct Shader, and as input we want our VS output, and then for that we're going to hit our in, and then we're going to create a semantic on that, and it's called SV underscore target, and then that, let's see if it builds. Okay, it is SV target. It's still expecting a parenthesis, and where this is coming from I'm not sure. And let's go ahead and try to put this value in here. And it still is problematic. Now I'm wondering if it's from this part of the shader that is coming along here. And let's see, if we go ahead and just enter this into here, and it compiles, but we are not getting any kind of, okay. Now this is a situation here, gang. Do we have boxy struct? Okay. And we have this information here. So I'm obviously doing something wrong. Okay. I'm going to get back to you next week, and we're going to say, hey, bub, what's going on here? Why didn't you get this working here? I am not sure. This is, I'm bumping into a ShaderEd tool because I did this about 4 or 5 times on earlier this week in order to kind of test this thing out. But it's still not working. Now, if you happen to be a shader programming wizard and you say, hey, dude, this is what you're missing, please feel free to drop in and tell me what I'm doing wrong. But it should work like this just fine. All right, cool. Well, actually, it's not so cool. I'm kind of peeved that it's not working. But it should be working. We should have a green object. And so if we were to go into, let's take a look at this other project. I'll go to File, Open Recent, and we go here to Project. No, File, Open Recent, go to Trial 2. Okay, now here we have is our project, rebuild project, Windows, edit code, all. Okay, there we have is our pixel shader, and we have this, and we have this, so we should be able to see something. And I've broken, seems like I've broken ShaderEd. Plain old, plain straight, I've broken ShaderEd and it's not working at all. Does it work if we have the planes? Yeah, it works for that, but I somehow have broken it so that it doesn't show up with the structures. Interesting, because this was working right before class. All right, let's try another project. I told you I did this a few times beforehand. I'm really kind of upset here that this isn't working. Okay, save changes. No, I don't want to save changes. Okay, we've got the trial. All right, so I'll have to get back to you and express what went wrong here, because when the old one isn't working and things aren't working properly, then it's just plain old confusing. All right, let's get out of here, and I'll set you on your way. So if you have an opportunity, practice some of this stuff, and then hopefully I'll have a little bit of an understanding of why this isn't working. But hopefully you're not having as much fun with this ShaderEd stuff as I actually have right now. Oh, I didn't want to show that. Okay, so what I'm going to do is move this forward. All right, let's get going. All right, such shenanigans. Anyway, check us out next week, which will be the 6th of August. Can you believe it's August already? Okay, and what we're going to be dealing on with HLSL struct textures. Now, we've got the basics of how to do the shaders, and now let's go ahead and let's show how to do the textures, and that's what's going to be next week. And I'm going to show you what went wrong here with the structures. All right, cool. If you enjoyed all the shenanigans going on here, go ahead and subscribe onto the YouTube, and then we'll see what's going on. And then otherwise, check me out. My name is Chris Rhoda on Facebook and on LinkedIn, or I check out TechArt EDU on Facebook and on LinkedIn. And if you're really up to an adventure, go to techartedu.com, and there's a little opt-in button there. So click here now to give us your email address to opt in for that, and I'll make sure that you get updated with all of the latest TechArt EDU news and all of the business that's going on with TechArt EDU. All right, great. Thank you very much. Thank you very much for putting up with all of the shenanigans associated with ShaderEd, and hopefully I'll have solutions for you next week, and when we deal with fixing those problems and dealing with HLSL textures. All right, until next week, arrivederci.